Welcome back. So we are moving on to lesson 1.3, unit 1, lesson 3, properties of graphs of functions. So here are some parent functions that you should have learned from grade 11. First, we have a linear function, y equals x, or y equals mx plus b. And that is just a straight line, pretty straightforward. Then we have a quadratic, y equals x squared. Once again, you've had enough experience with that one too, I would hope. Then we have a reciprocal function, y equals 1 over x, or h of x is equal to 1 over x. Then we have k of x is equal to absolute value x. Then we have m of x is equal to square root x, and then p of x is equal to 2 to the power of x, and q of x is equal to sine x. So here we have 1, 2, 3, 4, 5, 6, 7 different parent functions. And you are expected to be able to graph any variation or any transformed versions of these parent functions. And that is what grade 11 was basically all about. So we are going to expand a little bit more on that and basically continue with our knowledge of all these basic parent functions. Before we get into that, let's talk about some intervals of increase and decrease. So intervals of increase, what is that? The intervals within a function's domain where the y values of the function are getting larger, moving from left to right. Essentially, what that means is a positive slope. So kind of like that. Positive slope, interval of increase. If you're increasing, then it looks like you're moving to the right and up. And intervals of decrease is essentially the same thing, except to the right and down. So a negative slope. And that's that. Here we have some symmetry. And this is a little bit more difficult. So an odd function and an even function. So even functions are functions that have symmetry about the y-axis. What that means is if you were to take a mirror and place it on the y-axis, and if your function is equal on both sides, symmetrical, therefore it is an even function. So this function here, this example, you can see it's a mirror image of one another. If I were to place a dotted line here, and you can see that these two blue lines are mirror images of one another. So that is the definition of an even function. An odd function is similar in that you can take the mirror image, but you have to take the mirror image twice. So first you have to reflect it across the y-axis and across the x-axis, and then it will look exactly the same. So if a function, if you were to take a function and you were to reflect it across the y-axis and then across the x-axis, and then it would look exactly the same as the original function, then that would be the definition of an odd function. And that's called rotational symmetry about the origin, or point symmetry. And then we have one more category, which is neither. And neither or neither essentially just means that the function doesn't have symmetry either. It's not an even function and it's not an odd function. So most functions would most likely be neither, because if they don't have symmetry, then it's neither. So yeah, that's the definitions. That's graphically. Now, algebraically, there is another way to determine whether a function is odd and even. We probably are going to go into a little bit more detail later on within this course, but it has something to do with subbing in negative x into your parent function or your original function, and then solving it and simplifying it and seeing what the output is. So for an even function, if I were to substitute a value of negative x, then I should get the original function back. So an example of that is, let's say f of x is equal to x squared. So this is my parent function parabola, and we know that a parabola has symmetry, and so therefore it's an even function. So let's substitute negative x into this equation. So f of negative x, if I sub it into this equation, is going to look like this. And negative x squared, well, that's just negative x times negative x, which is also the same thing as x squared. And you can see that this x squared is exactly what the original parent function was. So every even function has this property where if I were to substitute a negative x value into the original function, I would get the same original function after simplifying. Now, odd functions have a different property. We also are submitting negative x into the parent function. And let's say our parent function in this case is x cubed. X cubed is the definition of an odd function. Now, if I were to input a negative value of negative x into here, I will get negative x cubed. And negative x cubed is the same thing as negative x times negative x times negative x, which we all know is just x cubed, but negative times negative times negative. Well, the first two negatives cancel out, and then you're just left with a negative left over. So this is not the original parent function, or the original function rather, but it is the original function times by -1. And that is the property that odd functions have. They have the property that if I were to input a negative x value into the odd function, then I would get a value that is negative times the initial parent function. And this is negative times x cubed, because if I were to take away the negative sign, I would get the parent function. So that's your definitions for odd and even functions. Here we have continuous function and discontinuity. Continuous functions are functions that don't have any holes or breaks over its entire domain. Another way to look at it is if I can graph this, if I can draw this graph without lifting up my pencil. And if I can do that, then this is a continuous function. In this case, I can do that. Discontinuous basically has a break or some, point of discontinuity. For example, here, if I'm graphing this like this, there's no way for me to continue this graph without lifting up my pencil and then starting off from here. So you know that that's one way to determine whether a function is continuous or not. All right, thank you.